here at 17. I'm not even that old, it's amazing, isn't it? Well, it's an amazing turnout. Thank you all for turning up at this event. We've got a really strong conference program that's been curated by our conference producer, Kisanka. Kisanka Moses, are you in the room? Well done, Kisanka. You got them all in the room. So, brief intro, you know who we are, DCD. We have websites, we do training, we organise events all over the world, and we're really happy to do it. And you can just see here today, the industry keeps on getting stronger and stronger. So, you're here to listen to this panel, so I'm going to stop talking, and I'm going to introduce you at the end of the table to Kelly from 451, who many of you know, all of you know, the industry knows. And she's going to introduce our wonderful panelists today, and we're going to get cooking with a really nice discussion about what the future holds for this industry and what clients and users are going to be looking for in the future. So I'll hand over to you. Let's give them all a warm round of applause, please.
Thank you. All right, so we have such a big panel, we did not fit on the stage. So you may have to stand up if you want to see people, but we'll do our best here. I'm Kelly Morgan, so I'm the head of data center coverage at 451 Research. We write about IT, especially new and emerging technology, and there are about 10 of us devoted just to covering data centers. So we roam the world looking at them and talking about them. So I will mostly get out of the way and just ask questions because we have such an amazing panel here. But first, I'm going to have them all introduce themselves, which will take us a while right there. So go for it.
Hi, Steve Press, Vice President of Data Center Operations for Kaiser Permanente.
Skylar Holloway, I work in strategy and planning for data center connectivity at Facebook.
Eddie Shooter, the CTO for Switch.
Steve Schwartzbeck, HPC Analyst at Northrop Grumman.
Zaid Khan, LinkedIn.
Dean Nelson, formerly of Uber.
And I'm Chris Orlando, the CEO of ScaleMatrix.
Great. So the way we thought we would do this, rather than have, say, one question and have several panelists answer, I've got individual questions per panelist, and then hopefully we'll have enough time for a few questions at the end. We'll see. So I think, let's see, who do I pick on first? I'm going to start at the far end, maybe.
Thanks, Kelly.
Yeah. So, Chris, the amount of compute required by deep learning and algorithms, AI, has jumped 15% from 2015 to 2017, roughly. So, huge amount of compute going into AI. How is ScaleMatrix kind of designing facilities that help deal with that? What are some of the challenges?
Sure. So at Scale, we kind of looked at where the industry was headed and started to realize that water cooling was probably going to be a way that we could solve some of the future demands for customers. Our AI, deep analytics, and those type of things are driving densities higher, not for every user, but as the enterprises start to collect some of those services and utilize them more for traditional applications, you see densities increasing. Our average workloads for customers were somewhere in the 5 to 7 kW range across our colocation portfolio, and as we've spread out across the nation to 5 different data centers now, we're seeing customers still using those ratios, but for those that are adopting AI and other compute-intense workloads, we have customers that are kind of leapfrogging the 10 to 20 kW marker, and we're now seeing consistent workloads for those specific applications coming in between 30, 40, and 50 kW. It's a smaller portion of the market, but it's one that we see growing much more rapidly than we thought. And our market is really kind of going after those customers and showing them how water efficiency can be achieved to help lower costs without introducing anything too exotic into the mix. And we're seeing growing demand for that particular one. In our particular scenario, not having to introduce any risk from a water-cooled solution, still getting all the efficiencies of it at the cabinet level, that's where we're seeing the sweet spot. Not too custom, nothing that would slow down business agility or a customer's ability to respond to changing business demands. We think that providing a lot of flexibility at the cabinet level while delivering that great water efficiency is something that people are going to start to need a lot more.
Great, thank you. How about Dean, so in some of your past roles, you've had to deal with adding a lot of capacity really quickly, and you've also worked with pretty innovative firms and kind of innovating around the technologies around data centers. So, you know, how does capacity kind of affect, I guess, technology growth? What do you see in the future for trying to deal with some of these issues?
So I've had the privilege of working at some really fun companies, and I see faces out there of eBay and PayPal and Uber, etc. And I've always loved the portion of scale. And so being able to plan, and I mean, there's many people on this stage here that actually have a similar experience to that, even bigger. But how do you build an environment that will allow you to scale quickly, but still cost effectively, with the same amount of flexibility that doesn't paint you into a corner? That's a tough thing to do, and I would say just, if I look at some of the deployments that we've done in the past, they might have been too early. So I think about liquid cooling. We deployed in Phoenix a data center there that had liquid cooling to every rack, ready for it to be able to be, whether it's an in-row with liquid, or it's going to be a rear door, it's going to be a direct-to-chip, everything was prepared and ready, but the hardware wasn't ready. And then there's limitations from some of the chip manufacturers that say that all the benefits that they would get didn't materialize because they were controlled in a certain way. And so, can you be too early into something? You got to find that right balance. And I think that probably the cheapest investment is when you can do something at the beginning at scale first. That isn't a large amount, can be distributed over a large amount of time, you need depreciation. You give yourself flexibility. I mean, I just listened to what you're talking about with liquid cooling, and we all know that liquid is more efficient. We all know that you can get a lot of savings from it. But if you don't have a thing that's going to be cooled with liquid, it's a problem. And the majority of data centers don't have a liquid requirement except for what they're doing on the back end. So you got to make that trade-off call, I think, on it. But capacity-wise, if you look at air today, it still is. You can cool 50 kilowatt racks. It's proven by many people, even on this panel, with air. Can it be more efficient with liquid? Yes. Should it be? I think the thing that's emerging is AI, all the deep learning, the high optimized, meaning utilizations in the 80-90+%, think of work farms, etc. That is where you're going to start to get the biggest gains for it, but it won't be the majority of the data center right now. It's kind of these one-off things, and I know some peers in the industry that you think of hyperscale, you want everything standardized, deployed, I want to roll it in, treat it like cattle, and not worry about pets. But you got to think about the AI aspect of it, that it is kind of custom, and you got to figure out how to do that because it's expensive. It's really, really leveraged, right? And it can't go down still, I think, in a lot of these cases, but it's less than 10%, I believe, of what's being deployed. So there's, from the future standpoint with capacity, I think that the same strategy still applies. Standardization, flexibility in that environment to make sure you can land anything anywhere. And by the way, one of the things that I'm proud of, previous team here, is the flexibility that was built into the whole stack. Being able to roll a rack anywhere, the network's flexible. I don't have to worry about the network limitations, the cooling, the power. You have everything there that I can just land it where I need to and optimize the deployment. That's really important. But what's emerging right now, I think, is the definition. I listened to somebody this morning about edge, micro edge. I mean, there was like 7 definitions of it. It's kind of like cloud was before. What is cloud?
Yeah, exactly.
So edge is that new ambiguous term, and everybody's got a definition for it, but edge is emerging. Edge is going to be a significant player, period. There isn't a doubt about it, because what will happen is the demand will drive the need at those locations. It's just, what is it? And you know, one other insight that I've had in the last couple of years that I changed my mind was, we keep thinking of autonomous vehicles. Great, they're generating 4 terabytes a day, right? We should have all this data that's going to be coming off these cars, and it needs to be processed in the car, and processed at the edge, and processed. But the reality is, take the word autonomous, the car will do what it needs to do. And then you're going to take these snippets of it to be able to do something with that. But it's not terabytes worth of data that's coming out of each car. It's going to be sums of lots of cars. But do you really need all that compute immediately at the edge? Not necessarily from autonomous vehicles. Will other things need it? Yes. Virtual reality, augmented reality, anything that's mission critical when it comes to life and safety, latency, yes, it'll be there. But it's not autonomous vehicles. And that was different than what I thought before.
Yeah.
But I do see that the way that we define edge, and I think as the core will still be there, it has to be there. There's going to be a distribution. There's going to be an edge. There's going to be a micro edge, and then there's going to be little things, the IoT edge, that's everywhere. But that's just demand. It's all going to keep growing. Well, how do we deal with it? It's not the traditional way in which we build things today.
Yeah.
The edge will change all that.
Definitely. Yeah, and that leads right in. Actually, Zaid, I was going to ask you at LinkedIn about workloads that you're seeing. So we've talked about AI, but what kind of workloads are you seeing likely to come into play going forward in the future, and how will they impact your infrastructure developments? Could be edge, could be...
Yeah, very similar to what Dina was saying. So I'll talk a little bit about sort of workloads are what drives changes inside the data center. So everyone actually has uses the LinkedIn application. If you look at how you connect to people, how you go through your feed to see all the relevance of news that and all your peers in the community are reading, and then search. Those three things are very powerful workloads of LinkedIn. And underneath all of that is we have a long history of machine learning and now AI that's sort of driving that. What has been interesting for us in the data center journey is that we're completely driven by being as efficient as possible, and that included our first journey of saying, hey, we need to really dense up our compute inside the rack, and so we found innovative ways to do that, to put like 80-90 servers in a rack if we wanted. That included redesigning the way we do things, also bringing the water cooling down to the rack level. I think that AI brings a very interesting twist that only solves a certain subset of problems. But now we have to think about, okay, what is the efficiency? What is the thermal telling us that where's the efficiency lying in component level cooling? I think that we're not quite there yet, but this is the right time to do that study and figure out, because I think it's really around 500 watts where it starts to become efficient. But this is the time to actually start doing that. And to think about how then that changes the dynamics inside your data center. So these are the things that we're constantly thinking about, and finding that right trade-off to say, okay, this is the time to put this tech in and increase efficiency, because that's sort of what we want to do. We want to add more compute over time, but also I think that this journey will also pivot over time, because I think AI is going to be towards more specialized data. And that makes it a lot more challenging, because it's no longer easy to get great kind of things, and people will be building infrastructure on top of AI hardware. And then I think that's where sort of like it's a very interesting journey for cloud in itself, that it can position itself to say, hey, this is the place to come in and really get your compute needs for specialized AI hardware. So I think that this is kind of like future journey for the industry in itself. And so I think we constantly think about how these workloads are going to sort of change that. I think what's also that we can lose sight of and have that line of sight is that how does now with all the AI and ML workloads inside the data center, that's like high compute, high density compute, that will change, just to what Dean was saying earlier, that that at some point the edge will play. We don't really know what kind of workload will run on that. I think it's still the jury's out on that. But I think that we have a unique opportunity, in the industry to sort of help drive that. Are there going to be certain microservices? I totally agree that you're not going to be shoving terabits of data onto this, but there'll be a high latency sensitive devices. I think IoT will probably play a bigger role in that than autonomous vehicles. That's just my hunch. I don't know yet, but I think it's a hunch. The other thing is, I think that microservices, it's not like there's talk about like is the edge the cell tower, is the edge the device itself. A lot of people don't talk about like the edge. It could also be the CEOs themselves, right? Like the challenge with 5G at the moment is that it's a race, right? There isn't there's a lot of equipment to be upgraded, and we haven't had that in time. And disaggregation at that level has not happened. If disaggregation happened, then it's very easy to switch from 4G to 5G, and so that's another aspect. I think that needs to be looked at. So,
yeah, and following up actually on that edge kind of question, Steve, you and I were talking about how the edge for Northrop Grumman is actually in space. So how does that influence things like latency and challenges?
When we talk about an autonomous vehicle or an Internet of Things, you can imagine the Voyager spacecraft has passed the heliopause. Not that everyone here wants to know that, but there's a case where that object needs to have enough intelligence on board. It's been out there 30-some years, and it's got to maintain itself. So we're going to have a lot of computing that's just there and understanding what data really needs to be sent home. When we talk about a data center, that's going to be your system of record, that's going to be your key data, it's got to be secure, it's got to be 100% up. But we're going to have a lot of computation going on at the vehicle, either autonomous vehicle, your refrigerator is going to start talking back to you. So we've got a lot of things that are going to do that computation. So understanding how your network is going to actually get connected. And when you think about science fiction, you get Skynet. Well, Skynet is machines talking to machines and skipping the ground station. So that's the kind of thing that's going to start coming. When it comes to the data center, though, that's the data we're going to have to rely on. And that's where a lot of our headed is, to make sure that our data is there, secure, physically, cyber, the whole bit. So that's one of the considerations that we have going forward. We also have our management who likes to think, yes, we have 2 data centers for the company, that's all we need. Well, I have 13 different clusters, they're not all into 2 data centers. So we're going to have a hybrid model for the future where we have a lot of computation going on in one area, or 2 areas, or 3 areas, and managing that hierarchy of computation is going to be critical.
Great, yeah, and speaking of hybrid, actually, Eddie, I know covering data centers in the colo world, there's been a lot of discussion about the growth of cloud, essentially eliminating co-location but then when we do surveys of enterprises, they tell us, no, we're doing hybrid, right? A whole batch of things. So where do you see things on that sort of colo versus cloud?
Sure. Well, there's obviously some marketing material out there that says the data center's dead, things like that. So we've talked about that before. Uniquely, the cloud runs on data centers, so it's not really dead, I guess. Overall, I would say, though, that there is a shift, and enterprise customers and enterprise data centers really aren't in the business to run data centers, generally speaking. That's not where their core of expertise is, that's not where they make their revenue generally, and so they're looking for how do we shed those costs and move that over to other places. The cloud, obviously, if they can move their applications to that environment, then that's great. But what we're seeing is actually a realization of a mix of customers who have moved non-native applications to the cloud, realize that they don't run effectively in the cloud or financially effectively in the cloud, have moved back towards the data center, but still don't want to own the data center. So we have different numbers that we use, but I think it's safe to say that roughly most CIOs are looking for about half or more of their applications to move to a cloud-native environment and run there. Roughly about 40 to run inside of a co-location space, and probably that last 10 to 20%, they just can't let it leave the 4 walls of their building. And so when you think about that mix, I think today, still the statistics are that it's roughly only about 30% of applications have moved to the cloud. If you think about that scenario, that means that somewhere between 60 and 70% of the enterprise hardware that's deployed is still in their data centers. It's not, it's in a colo facility, or it's one of their enterprise. So there's a huge market opportunity there. On the hybrid side, I have not heard one CIO yet say that they were not, that the hybrid data center was not part of their strategy or the hybrid application environment platform. So I would assume that the next 10 years is pretty straightforward, that hybrid is a requirement, diversity of deployment of cloud, diversity of deployment of physical attribute, where it's located, will all be part of the mix of a portfolio for enterprise clients. For non-enterprise clients, this is sort of an interesting scenario too, and I'll make this very quick, but for non-enterprise clients and who would that be? I would say it's a lot of startups, a lot of research and development teams particularly, and then there's service providers and that kind of thing. For those clients, Surprisingly, what they're finding is that there's sort of a tolerance for really two delivery models. One is a resiliency model that doesn't rely on reliability from a redundancy model. And then there's a large amount of solutions that are requiring redundancy. Even at the edge, in the conversations about the edge, there's clients and customers who say, hey, we can build our applications to run on a run-the-fail model, and we can rely on alternate locations and alternate connectivity to provide us with services. On the other hand, there's customers like banks, for example, or point-of-sale solutions or things like that that really don't have or even hospitals who don't have the tolerance for any downtime. So I think edge is going to be a mixture of both. And the question is what that is that going to be? And then how many intermediate data centers aside from core is still really needed? There's a whole market of tier 2 deliveries that have occurred, but a lot of storage is occurring in concentration spots. You'll see that if you look at our strategy, you'll see that we've concentrated around the core strategy of deployment, and then there's an edge strategy that is intermediate to distributed level edge that will essentially act as an aggregation point, dependent heavily upon the ubiquity of networking and the availability of that connectivity.
Yeah. Interesting. So, Skylar, Facebook, latency, getting a little bit at that edge question. How does Facebook deal with kind of the need for low latency for some applications, maybe not for others? How does that, affect the way that you sort of, set up your infrastructure? And kind of, is latency the number one driver? What other things do you look at when setting things up?
Yeah, sure. It's interesting hearing the discussion on edge specifically because edge, I think, is used a lot to be a way to approach latency issues. And from the Facebook perspective, we look at it from very app specific and keeping in mind the user experience. So to think about that a little bit deeper, when we think about using something like compiling your newsfeed, the latency requirements of that might be drastically different from using Portal, for example. So I've got nephews across the country, and I'll talk to them over Portal. And in this example, latency is something that is very intrusive to the conversation, where they're 2 and 4 years old, and so they already have short attention spans. And if there's something that has lag in the system, then it takes a service from being successful to not successful. But in the first example of compiling a newsfeed or pulling up old pictures, the latency requirement is quite different. So we look at it in terms of the app, and we try to understand if we do go forward with additional investment to decrease latency, is it worth it? Because we want to be assured that when we do invest more, that we have a tangible benefit to the business, and that the end user will benefit from what we're trying to improve upon. So it's definitely focused on where do we need something like edge and where do we not, and taking a cost-benefit analysis between different apps on how we would approach it.
And has that changed over time? The cost benefits, the cost of network, how do you kind of project that forward too?
Yeah, certainly. It's kind of changed in 2 ways, both with the products that we offer, as well as the cost of the edge and our data center strategy as a whole. Traditionally, Facebook's products have probably not been as sensitive to latency requirements. As we start looking at virtual reality or immersive experiences, it becomes more important. So it's kind of striking the right balance of kind of like I think Dean mentioned earlier of how can you move towards new technology not ahead of time, but striking a balance between when it will work for you and when it's actually required, so that you're not jumping too far ahead and investing money in ways that don't actually benefit the bottom line.
That's interesting. Yeah. So Steve, Kaiser Permanente, huge, right? 13 million people being served. Very large company, regulated industry, complicated requirements. You've been kind of making the move toward private cloud. How has that gone? What have been some of the challenges kind of determining the strategy?
Very, very slow. Yeah, no, we're not early adopters by any means. As Dean mentioned earlier, we're built a data center, got it ready for water cooled, and then the hardware wasn't there. You know, we're building our network, obviously, and you know, we have a number of carrier neutral facilities stood up, and the network team is ready for that. But really, there's so much around regulation that has, you know, between HIPAA, SOX, PCI, and for us to get our agreements in place so that our audit chain can go from Kaiser's data centers to our cloud providers and back, and who's responsible, and working out all the details around that has really been you know, a huge undertaking. And then in healthcare, usually the applications are not developed as cloud native. So to re-architect you know, our application base, because you know, we've been in business now over 70 years, so you know, there's a significant already in place application base that would have to be re-architected. And one of the other big issues we have in the cloud is the interfaces. So, you know, one of our mission critical apps interfaces to more than 70 other mission critical apps, you know, in our environment to pull all the information together to take care of our patients. So to make all those interfaces work in the cloud between our data centers and our cloud providers is, you know, quite the undertaking. So we're ready, but it's moving a lot slower than I think you know, we had originally forecasted.
Interesting. So I'm going to hop around and go to the other Steve. You have been installing high-performance computing, I think. How has that gone? You know, how complicated is that?
Well, high performance computing, anywhere from, we still have an SGI that is water cooled, which is a little annoying when we have to move that asset physically from building to building, because it means I've got a 3-month contracting exercise to get the plumbing done right. So that's, most of our stuff is air cooled. We use a mostly Beowulf cluster. The ones I'm working on support our production design, and we're starting now to get requests for a lot more artificial intelligence work. Some of it from our engineers who want to do their own desktop cool artificial intelligence cluster, but we're getting the requirements and actually building out something in the data center professionally. So that's one of the things I'm looking to get some information is just what better architectures are. I've heard FPGAs for some neural network type of things. But we're in the researching end for a lot of that type of stuff, so I'm going to be throwing away a lot of FPGAs because they're just not meeting the needs. So that's going to be a bit of a trend.
Great, thanks. Maybe jumping down to Dean. How about infrastructure ownership? I think you've probably given this a lot of thought in your various roles. Where do you see that headed? Are there some kind of innovations? Are there new things required? What ideas do you have on that?
Yeah, I think Eddie pointed right. The data center is dead. We should all just quit our jobs. So there's a phrase that came up multiple times just in the last 2 to 3 years. It's an and, not an or. And the reason for that is that we keep saying it's going to go to cloud or it's going to be on-prem. When we talk about hybrid, the reality is it's going to be percentages. So first off, cloud can't serve everything that everybody needs, but they can serve a lot. They're a hyperscaler for a reason. They've got platforms that support quite a bit of work, and that's why startups and everybody else can go there and get going really quickly. But as you start to get bigger, you have the economies of scale that come in. And the issue is that when you cross that line, because at some point you can't afford to be 100% in cloud, and I know cloud providers probably want to hear that, but there's a thing where, and I think it's in the 50,000 server range, probably 50, 75. Once you get to those, you can do these economies of scale about how you design your own data centers, how you actually deploy your network, how you do your hardware, and that's the biggest key. You can get the same scale and cost reductions that are happening in the cloud. But you're also not as big as the cloud players, so that means you're not everywhere. And so this is where the and comes in. So if you expect to go back and deploy globally, you're not going to have enough money to get the best economies of scale. Then you've got two cloud providers that are enabling capabilities. So for example, everything was terminated for edge. We just talked about this before. There's already an edge deployment in many clouds that you can leverage. So you can put your front-end servers all over the world very quickly, cost-effectively. And you can address a lot of those latency things by moving things to that edge portion of it. You don't need to build all that out. And then you look at, if I need to go into Europe, GDPR is thrown in. There's some other thing that drives me to say I have to have something local. Are you going to go build out a 3-zone region for your deployment inside of that country? Not day one. And especially if you're at the 50 to 75,000 range, when it comes down to servers, you have to leverage somebody who's got infrastructure there, or else you're making very large critical capital bets that can backfire on you, and you don't want to have that conversation. So the hybrid approach, or the tripod, is to say, I can go into any region, leverage cloud to be able to turn up. And when you get to a certain size, then you can flip it back on-prem. That's a business call. But the point is it's an and. So the cloud providers are here providing a very good service, and when you get to a certain size, you start to replicate what they're providing yourself. And the one thing that I would tell everybody, at least what I've seen, is if you do not have a clear taxonomy and understand all the elements of your stack and where your money is going, you're going to waste some big dollars, and you're going to make decisions that are uninformed. And once you have that, that's kind of the golden nugget. Because you can go all the way to the C-suite and defend why you're doing what you're doing. If you don't have that, you can't back up what you're saying. So the taxonomy is really important. And I will say that it is a race to zero in a lot of this stuff. And why I say that is that on-prem is the price leverage for cloud. So there are going to be contracts that are signed. The cloud is a multiple-year contract. On-prem is a multi-year depreciation schedule. You're still spending X amount of money. It's just who you're going to give the money to and how much. There's going to be a percentage of that tripod, and it just comes down to who's adding the most value and where you need it. Does that answer?
Yeah, definitely.
If I can add something to that, I think a lot of organizations forget that today they may have 100,000 machines and they're in a rotation every 3 years. They forget that when they move 30% of their equipment into the cloud or 40% of their equipment into the cloud, they've lost the buying power they have with the OEMs or ODMs they were working with. And that has a chain effect on the entire cost of the application. And so when they discover that the cloud costs them more than they thought it would, they don't get to go back to the numbers they were at before. They have to go recycle and redevelop new relationships with new forecasts and new demand in order to get those numbers back. And so it's a fairly significant shift for that digital transformation to make a commitment like that. But if you miss, it's very expensive to the organization. It'll take 10 years, 3 to 4 life cycles to catch back up and fix that.
Yeah.
So there are interesting vehicles out there through cooperatives and other things that can help to address some of that, but a lot of people don't know how to use those, and they're finding themselves sort of stuck with an application that was maybe $1,000 a user suddenly becoming $5,000 a user.
Yeah, and people wouldn't realize ahead of time that could happen. Yeah, definitely. I think maybe talking about some future stuff a little bit. Zaid, I know LinkedIn, you're a supporter of open standards, open hardware, and that's driving some innovation. But do you think there are new things coming out? 5G is one example, but other things that could impact kind of where those open standards need to go?
Yeah, that's actually, so yeah, from the context of future edge and all that, I think there's going to be future, but let me dial back a little bit. Open hardware is an amazing space. It's young, right? When you think about software, it's open source software, super mature. You can write a piece of code with an Apache Foundation, or let's say a Linux Foundation. You can move the code around depending on where your preference is, which is really great. Open hardware has gone through some very interesting tracks. One is like, obviously, OCP had started very big and opened up doors for doing something very specialized. And I think when Facebook sort of like said, hey, we want 21 new tracks, we're going to open it up. That's great. And to go fast, they needed to do that, and OCP came about, and the community grew. We at LinkedIn, didn't have the same set of problems, so we came up with Open 19 because we wanted to solve for the 19E track. But at the end of the day, from a back level perspective, we were also building a computing rack hardware, right? And then when I was in China like 2 weeks ago, we were talking with the folks at Baidu, and they came up with Scorpion, and they have a very similar thing, right? So as I step back and think about this, it really occurs to me that we as engineers, you want to go fast, you go alone, right? You just say, I'm going to go fast, I'm going to build this thing, I'm going to solve for 19-inch, I'm going to solve for multiple kinds of SKUs inside a 19-inch, I'm going to go do X, and somebody else goes there. But when you want to go big, you have to go together. So I think that we're at this point where we've decided, when you look at 5G coming down the road, and the reason why I say this is because I've heard discussions that, hey, let's build another standard for 5G edge, when we start to deploy in unknown buildings and inside mobile stations and all these, we'll need like very specialized sort of rack level and all that. And so another offshoot, that's to me is like, what problem are we trying to solve? It's a two-dimensional problem. One is you only have so many engineers that are going to work on these problems. That's one. The second is you got the supply chain on the other side who's going to say, well, where do I invest? Who's going to be the winner? So I think there's some really interesting discussions I've been having with OCP and I was in China as well. We all kind of feel that, hey, in the community, all these rack architectures are very similar. Let's combine and try to collaborate and solve for the things that they're doing, because at the end of the day, when we do have to get ready for 5G and installing smaller racks in closets and all that, we will need a very, very simplified architecture. You can't send your DC techs to go and change something out in the middle of nowhere. You gotta build something that doesn't break that often. And so there's a need for that. It's just that when you start to think about that problem and have like several foundations that try to solve the same problem, that's really not gonna be good for the industry. So again, when you want to go fast, go alone. When you want to go big, like 5G, go together.
Great, thanks. And speaking of China, so earlier this year, a surgeon in China performed the world's first remote operation. From the Kaiser Permanente standpoint, you're talking about latency and reliability. What kind of cutting-edge applications is Kaiser looking at, and how does that impact your kind of technology plans for the future?
Yeah, I think the biggest area that we're going to need help from the industry in when it comes to cutting edge is wearables and Internet of Things on people. When you think about the ultimate edge or the micro edge, you are all in, okay? And your little mini data center is right here. So the problem's going to be for us to do critical life monitoring, in healthcare, is to get the information back from the wearables, from your mini data center, reliably back to our data center, either via the cloud or via our networks. But that really, I don't think anybody would trust this yet. Everybody has dropouts and 5G. We don't know how reliable it's going to be, but supposedly it's supposed to be more reliable than this. But when it comes down to doing real life monitoring of every one of the mini edges sitting out here, that's going to be a real issue, getting that kind of information back from each device to our data centers to where our doctors can do something with it.
Yeah.
Especially if you're doing cardiac rehab monitoring and you miss an incident.
Right, because someone else is watching Netflix, right?
Yeah, whose fault is it? I
Yeah.
mean, you provide the ISP, you blame the ISP or the cell phone device, or and I don't think anybody would trust their home network with that yet. So that's probably the biggest issue for us in healthcare, to really do some incredible things down the road when it comes to the Internet of Things.
Right. And then I guess speaking of kind of new future applications driving infrastructure, so Facebook announced cryptocurrency foray. So that could lead to a lot of impacts on infrastructure. What are you kind of thinking, planning ahead for that? What are some of the implications?
Sure. Kelly, do you want the real answer to this one? It's that we don't yet know all of the impacts.
Yeah.
how our data center footprint will evolve to provide something like a cryptocurrency and to such a massive number of people is something that will be figured out in the time frame ahead of us. But it's not a surprise that Facebook's developing new products or looking for new services to be provided. So it's something that we've looked at for years now, and how can we build a flexible and robust supply chain to be ready for something like this, or maybe an acquisition or other expansions that Facebook would perhaps follow. And at Facebook, because of the scale we build at, a lot of times the supply chain of getting a signal load capacity all the way through serving traffic can be rather lengthy, looking at 18, 24 months in terms of land development all the way to having capacity live. So we've traditionally taken a few different strategies in order to try to minimize that time frame, which then allows more flexibility into our supply chain. So some of that can be strategically buying land that we may need in the future. Also, we tend to buy land that gives us the expandability of our existing campuses. For example, I think that 14 out of our 15 data center campuses worldwide have ongoing construction on them today. And in addition to that, I think being very accurate on what are our future needs as best we can predict them, but also communicating that to our vendors and suppliers so that they can be prepared to scale with us. A lot of times in the past few years, we've seen that we're prepared to build rapidly and build at scale, but we have to remember that sometimes the numbers that we're pushing and timelines we're working towards also have to be obtainable for those that we work with, and that day in and day out are the ones that help to deliver our capacity. So I guess in summary, you can't really know what will be coming down the pipeline or know the knowable per se, but we can build flexibility into our supply chain so that we can react dynamically to changing business needs.
Yep, and a lot of that sort of essentially partnering with your suppliers and supply chain and trying to work with that, right?
Yeah, absolutely. I think the word partnership is kind of summarizes that one up, because it really has to be a two-way flow of information, even sometimes information that might be something we don't necessarily want to share more broadly, but to show this is what we're planning for the future, and these are the types of quantities we might be looking at purchasing, or other similar things, so that they can be staffing up teams, they can be building out manufacturing facilities, so that it doesn't come as a surprise. Because if you don't take a multi-year approach to this growth, sometimes you can't react in 3 or 6 months to the needs that are required to meet our plans.
Yeah. And speaking of partnering, at the close of this conference, we've got NVIDIA giving a keynote, and Chris down there at the end has become an NVIDIA partner. So how did you guys go about, I guess, developing that partnership, and how did you think about it and why?
Yeah, so that's an exciting one for us. So we've heard Dean talk about scalability and balance when you're trying to build data center resources and match them up with compute demand and all those type of things. We heard Zaid talk about the evolution of applications and how all those things continue to change. And everyone on the panel basically talked about edge in some way, shape, or form. So what does it all boil down to, right? It means that we're facing a enterprise application world that's extremely dynamic. And so when we kind of started looking at our data center design, we knew that we needed to match dynamic capability deployment onto our data center floor. Some racks are going to be 5 kW, some are going to be 10, some are going to be 50. And we need to be able to design for that capability without costing ourselves efficiency and without stranding resources there. So in our quest to design that platform, we ended up with a modular solution that's water cooled, that provides a lot of scalability and flexibility in the data center. We built that into a modular solution and started turning it into an edge platform. And as we started talking about the folks at NVIDIA, they're creating demand generally around AI, but in a lot of very interesting verticals. And one of the challenges, along with that is, hey, are all these enterprise class data centers today ready to be able to support that demand? So through the partner program, through their DGX Ready group, they said, hey, look, we're going to enable these data centers to take on those workloads for customers. And we joined them at their DGX show, or their GTC show earlier this year, and I was floored to see that while there were a tremendous amount of co-location opportunities for hosting that type of workload for customers, that 20% of the customers that spoke to us at that show were talking to us about edge requirements. So as they come out with their new EGX product, and they start looking at taking even higher density workloads Not necessarily in our core data centers, but all the way out to the edge. Our partner capabilities match up really uniquely with the demands that they have. It's a similar track that we had recently with HP. We decided to host their High Performance Center of Excellence out of our San Diego Innovation Center. It's because we're trying to eke every bit of efficiency out of every single cabinet while pushing the envelope of the compute that's within so that customers can see a real return on that overall compute investment. I think that's the genesis of both the NVIDIA and Hewlett-Packard partnerships.
Yeah, and it'll be interesting because I think the edge, maybe has been underestimated in terms of the innovation that'll be needed and the types of compute that's going to have to go there. Much more high density, high profile, can't go down kind of workloads that'll be there.
Yeah, I mean, the panel said it. We're starting to see those workloads evolve in all kinds of places where maybe data centers don't exist today. Dean said there's 9 different types of edge, right? Your data centers, our data centers, the edge, the cloud, and all those things in between. If we need to get data center capacity closer to where the data is being created and the decisions are being made, those form factors and capabilities have to be looked at very carefully, and we're evolving some pretty unique solutions for that, which is what all those partnerships are about right now.
Yeah. Well, I think we have a little bit of time. Where's Cassandra? I think we have a little bit of time in case there's some audience questions. So, yes, there's one in the back. I don't know if someone's got a mic. Ah, there's the mic. That's way. In the very back.
Hi, my name is Kevin Chalonsky, and I have a question regarding this high-performance compute. I think a lot of companies, especially if they own their own data center, got caught off guard because you had this hyper-converged equipment come in, and it's ranging from 25 to 50K per cabinet. 25 to 50 kilowatts per cabinet. So, from what you're seeing right now, or let me put it this way, from what I'm seeing, this is kind of devastating some of the data centers. They weren't ready and equipped to handle this, especially older data centers. Do you foresee that demand decreasing per cabinet, or do you see that as a trend for the future?
Well, I think I can take that one. We're looking at a lot of hyper-converged infrastructure for our medium-sized points, our closed rooms, things off at our customer sites. When it comes to the data center, to your point, when you bring a lot of that converged, what we're seeing is you bring that, it's really cool, software-defined networking. I don't recable my data center but every few years, so I'm not getting a lot of that benefit in my main data center. So I'm leaving those as pretty much traditional racks, doing some, overhead networking, improving the nodes that we have in there. But that hyper-converged type of thing is where I don't have the choice to do a conventional rack. I've got some constraint size, power, not so much, or cooling, where I can't have every little bit. Usually it's personnel. I've got to be able to drop, ship some big box, and have it work like a network. So that's where hyper-converged, the different devices fit in our strategy, is we're putting them where we can't do a real data center, or where we don't need it for all that long.
Interestingly enough, so I'm obviously a location provider, and because of our designs, we can handle north of 50 to 60 kilowatts with air, and that's in a multi-tenant space. So I would just say that one of the things we've discovered is even though the capacity has been built for a 50 and 60 kilowatt cabinet, they still operate at roughly 40 to 50% utilization on an average basis. There are cycles when the plants will run modeling solutions and things like that, but there's a high density demand and yield at the moment, but that doesn't last forever. So it's interesting to note that even though the fear of the hyperdensity scenario, same scenario we had back in blade technology, or if you're as old as me, back in mainframe days, but those same concerns about density overtaking the capacity of the floor, still operationally, the applications are operated similarly the same way they always have been. they never fully consume everything that's available.
So there's some volatility in demand that is why you have to spec to one type of thing. That's also part of the difference between what we do on-prem and what we would push to the cloud. If I don't have any volatility, I'd rather have it in my data center.
And I think if I could expand on that too, I think that might be an unpopular answer, but the reality is that when you start to throw in things into a data center that it wasn't designed to handle, you have to do some customization. And when I've got something deployed at 8 kilowatts on average across these things, and I throw a 50 kilowatt cap in the middle of it, you're going to strand something. You got to redeploy something. And so it might be best. I mean, you just heard Eddie talk about it. You may have to take certain workloads and certain capabilities and say, that needs to go into colo or that needs to go into a cloud. And I need to rethink exactly how I approach if I'm going to build another data center or retrofit. Kind of create that flexibility and modularity and other things with flexibility into it. So brownfield environments have limitations, of course, we all know that. And you may have to just do some customization if it must be there, if there's a local requirement for connectivity or security. But I think unfortunately, there is no magic bullet or magic pill for all this at one spot. You're going to have to do some customization to handle those densities.
Yeah.
Gene?
Yes, thank you very much, Dean. Gene Glassman from Hurwitz.
Oh, wait, can you keep the mic closer? It's hard to hear you.
Closer?
There you go.
How's that?
Rockstar.
Gene Glassman from Hurwitz. I just wanted to ask about multi-cloud. Pretty much every conference we go to talks about multi-cloud. And the implication there is that the individual customers, the large ones like the Kaiser, Menzies, or Northrop, will see a mix of several providers in addition to what they have in-house. And I know we've been talking around this, but how does this affect what we used to call capacity planning? How much do I get from provider A, provider B, provider C? How much do I do, probably 20% or 30% in-house? How does that impact capacity planning, and what kind of thinking is going around about how capacity planning is going to change when so many resources are out on the net for compute and storage as well? Thank you.
All right.
Let's start with LinkedIn.
You first.
LinkedIn.
So I think capacity planning I'm going to answer from a supply chain perspective. I think we're very interesting. When over time, I think that as cloud keeps going and you have maybe 3-4 cloud players, there will be a huge competition for getting the supply chain, the resources that you need. And I think at some point, as we get into a specialized hardware, it becomes much more difficult because you'll have to compete for the same types of things. Right now, SSDs were a huge capacity crunch, right? About a year and a half ago, when everybody was competing for it because that was competition with this as well. So the component level that you need to sort of build these are things that will be shared across. So I think that actually that will start to then infringe on folks that are trying to build on-prem as well, because now you're suddenly a smaller player trying to get the same type of gear, and you're going to compete with the same level of resources, which I think will take things in two ways. Like one is you will identify that, hey, I need to, in order to make my business work efficiently, effectively, I need to be on the cloud so that I don't have to worry about this supply chain problems. That's one, as opposed to sort of like saying, hey, these ones I'm super comfortable with it on my on-prem. But some of these AI workloads that I need to do, I absolutely cannot compete enough to bring them on-prem, so I'm going to go use the cloud for that. And I think that the cloud providers would eventually compete enough to sort of solve this problem. So I think that's where the chips may lie.
And a quick follow-up would be that the large companies like LinkedIn or Facebook are going to have less of a problem there in getting attention than that next tier down, which are going to be mid-sized to somewhat large companies. Everyone's going to pay attention to what you're doing.
Right.
But what about to the smaller ones that they're consuming the product as well?
So if I could add on to that, because I don't know if that's actually accurate. The reason I'm saying that, not to be contrarian, but this is a difficult problem. And the reason it's difficult is there is no cloud-first strategy that works. And I'm saying that with all due respect, that no matter what, you have to adopt something. If you go down to the very basic layer, you're going to say metal as a service. Can I standardize this unit to this unit in this location at this cost? That's the very bare bones of it. And you can get capacity, and then you can say, but I need IaaS on top of it. I need some way to engage with that capacity. So when you think about a capacity planner for overall, whether it's LinkedIn or Facebook or Uber, et cetera, they have to figure out where they're going to deploy, and then they have to have a mechanism to be able to deploy it, which means that they have to have some interface that extracts away everything underneath. So you can go turn up stuff at AWS and Azure and GCP as Metal as a service or IaaS, and then you're going to land your stack on top of it. If you're doing it on-prem, you have to have your own abstraction layer to manage your own in that manner too, which I know everybody here has built. But then how do you manage all three of them or four of them in parallel, and how does a capacity manager handle it? They just want to press a button and say, I have capacity in the right place with the right DR applications, the right GDPR compliant. I mean, there's a whole bunch of complexity in it. So there's no single answer to that again. It's consultants will make a lot of money on this.
I think you've identified one of the best use cases of AI right away. Is how do you handle a hybrid cloud configuration? Right? I'll just leave you kind of these two sort of rules of thumb that have continued to be true for my 30-year career. One is power is the currency of everything that's going on in that integrated platform. And secondly, end-user experience drives whatever the architecture of the distribution model will be. If end-user experience fails, the business unit is paying for the app, or it's the revenue stream, then it's going to change the design anyway. And if you don't have enough power, you can't grow, you can't meet the scale requirement, and if you're paying too much, it won't pay for itself. So those are two factors you never change.
Or we could adopt our capacity planners and just assume cloud equals infinity.
Well, I like the idea of using AI to figure out where to put your AI. More questions?
Hi, Michael Rose from SNIA. You talked a lot about the future really from a perspective of continuing to scale deployment around architecture and not really some of the disruptors in terms of new medias that are coming and new computational architectures. What are your views on that for the disruption and the needs of the future industries?
Disruption.
Well, disruption, I mean, we're going to try to do 1,000 microbit node just for fun. If you've seen the little BBC microbit learning machines, we're looking at ARM as moving some of our workload off. One of the headaches that we have in the HPC space is a new chip, a new architecture comes in. Who's coding for it? Where do I get that labor? So I can build up a ton of capacity, but until I have an engineer who understands how to use that, back to the IaaS and the rest of just the platform, it's sitting there idle. You know, I bought GPUs and thrown them on our high performance stacks, and I've got 5 people out of the company who use them well. So that's where, when I hear something coming in, I started in superconducting supercomputers way back in the day, and it's still about 30 years in the future. So that's where it's often critical to find your use case to bring that technology in and find where that niche is so you can get the engineering talent to make that hum. And that's kind of the unknown. It's, if you give me the killer chip, I've got some people I can work on it, but I'm going to have to work through my kind of space, military type of things to see what it can bring it out before it's going to get into general use. Kind of before Facebook or LinkedIn really wants to try to probably put it in the field somewhere.
Interesting. Yeah. More comments there? Or should I see? I think there were some more questions.
I have one I think that if you want a glimpse of the future, look at gaming. So all chips, network demands, latency, all those things come out of
It's kind of like games are going to drive the hardware platforms.
Yep.
And then entertainment cat videos are going to drive the network.
I also think that the augmented reality, virtual reality, as mentioned before, that will drive the low latency requirements. I used this example before about, you put on Oculus glasses and if you have a true virtual reality experience, you need to do 240 frames a second or else you're going to get your equilibrium off and you're going to throw up. And so again, gaming is going to drive a lot of it. But I think, Eddie, you were talking about this before, where when 5G comes out, It's not the technology that's going to save everything. It's going to open the door and the floodgates for people to innovate and drive even more. And that, I think, goes back to your statement around the demand.
Around for a long time. Are there any big shifts that you guys see are now reaching the point of cost viability and operational viability, whether it's liquid cooling or some of the end of road kind of discussion on how to build clustered compute and network, including kind of Tor, leaf spine into an end of row model and use that as a bigger architectural or modular building block for better scalability and lower cost?
Yeah, first time. So I think that it's a multi-dimensional problem, right? One is I think that networking will be super interesting to the point where it will be completely like living in a programmable world where you're actually programming the chipsets, you're actually influencing sort of like your data path directly. I think that those elements of SDN is already happening in the data center. I think there's going to be more exciting things coming along that line. I also think that we see now the trends of like eventually there should not be any sort of human that connects things inside the data center anymore. And part of our evolution of mobile networking was that at the end of the day, you just go and use blind read connectivity to get started. But I think the future is like robotics, right? At that level, if you take it from a metal perspective, I think that a DC technician that goes in, installs a switch, turns it on, and the switch knows whether it's a spine or leaf itself. Like that level of intelligence is something that we've been thinking about putting on the Tor, and then hey, I'm a switch that's a spine, I'm a switch that's a leaf, right? So those kind of intelligence, really at the end of the day, the switch becomes like a server that's already sort of being thought of. And protocol level-wise, I would say that there's more innovations coming where you can actually see workloads and say, hey, this is actually, it's not just TCP, right? I'm looking at, this is actually a Kafka worker sending to like a number of consumers, so I need to handle this traffic differently. That level of labeling at the protocol level, I think, is going to be seen more inside the data center, and even towards the edge as you want to identify traffic, because you mentioned that probably will go to the edge as well.
And I gotta just jump on one lane there, because it's all right, I mean, I talk too much, but if you approach this from a business standpoint, where's the money spent? Where's the most money spent? It's in hardware. Where's the second most money spent? It's in data center, and third is in network. So, there's a number of people out here that I'm pointing at one right now that knows this really well, that, if you can solve the core problem, in other words, optimizing the cost of that one, you should overbuild the other ones to give yourself flexibility. In other words, can you set up a network to say, I really don't care where a rack lands and what it's doing, whether it's 50 kilowatts or whether it's AI or whether it's, a Kafka cluster or something, I should have the flexibility. But that is, you need to have the network layer covered, you need layer 3, you need all the other aspects on top of that, plus you need the power, plus the others. You need to build on that flexibility. So the emerging technology, I think, on the foundational infrastructure pieces, build in the flexibility that allows you to scale for the future. How long is this data center going to live? How many iterations or tech refreshes am I going to do? And do I need to replace the network every time? You can't afford to do that. It's too disruptive. So build in for refreshes already. So there's some ways you can enable the future without limiting yourself, without wasting a lot of money.
Awesome. Thanks, guys. Zay and Dean.
We have time for one more. Yeah.
Hey, I'm Bill, big fan of you guys. I've been geeking out with everything that's been talked about. The questions have been great. So Steve, I agree with you as far as like we are the edge. I think we're walking, talking, data generating engines. And I absolutely agree with you, Dean, that it's not an and, it is an and, not an or conversation. My question to you guys, and this is pretty much anybody on the panel, is to sustain exponential growth in the future of digitally connected environment. I understand it's going to be a cloud and I understand it's going to be a co-location.